Hi guys. So I'm Taylor. Thank you for joining us here at the MEEC today. We're going to talk a little bit about marine mammals, what makes them different, what makes them the same. We're going to start off with a little presentation, but I will have the chat box open, so feel free to ask questions as we go, okay? Let's see, share screen. Okay, perfect. Let me bring this up. Okay, everyone can see me, everyone can hear me? Good? Yes, awesome. Okay, cool. So today we're going to talk about marine mammal morphology. First, we're going to talk about what makes a mammal. Let me see. I don't think I have the chat box open. Let me see if I could add that. If anybody wants to add a chat, feel free. Security chat. There we go. Okay, cool. Here. So feel free to answer things as I ask, but otherwise I'll just start filling in the blanks. So what makes a mammal? First, they have hair or fur. So that even counts for marine mammals, even though a lot of the ones that we're really familiar with, really comfortable with, like dolphins, whales, things like that, we don't think of them as having fur. We don't think of them as having hair like we do. They usually are born with a little bit of fur, a little bit of hair, some whiskers or something like that. And that does count towards the having hair or fur necessity. So they're warm-blooded. So there are ectotherms and there are endotherms. If anyone's been to the MEEC before, you know Captain, the sea turtle. She's a reptile. She is an ectotherm. So she can't regulate her own body temperature. We have to make sure that the water is warm enough. We have to make sure that her environment is warm enough for her. But chat. Oh, there we go. I can add chat. Perfect. Live birth. That is a good one. Perfect. So they're warm-blooded. Most are born alive, exactly. That doesn't include one of them. It doesn't include the monotremes. Does anyone know what a monotreme is? Possibly, maybe? It's actually the platypus. So the platypus counts as a mammal. It does have fur. It does have all the other requirements, but it actually lays eggs. It doesn't give birth to live young. And then finally, the young feed on the milk of their mothers. So they nurse. Same thing with, like we have over here, dogs, elephants, all of those, monkeys, they nurse just like people do, just like mammals do. So marine mammals do the same thing. So challenges of the marine environment. So it's very different for mammals to live on land versus in water. And here are some of the things that make it difficult for them to live in water. There's oxygen limitations. So they breathe air just like we do, just like Captain does, but they can't actually breathe it constantly like we do. We have air available to us all the time. Right now I'm breathing as much as I want. But when you're swimming, when you're diving, there's oxygen limitation. You actually don't have access to the air all the time. So they have to sort of adjust how they act and adjust their anatomy to deal with that situation. Movement is also another big one. So if anyone here is a swimmer, maybe, yes, it's a bit of a workout to swim, right? Doing a bunch of laps in the pool, it's a huge workout. It's much more difficult than just moving around in air. Me throwing my arms about right now, that's hardly any energy because air doesn't cause a lot of friction. It doesn't cause a lot of issues for me, but water has a lot of friction. It's a lot of effort to move through water. Sound is another one. So sound moves 4 times faster in water than it does in air. It moves differently and they hear differently, so they have to adjust for that. Salt, so being in the ocean, it is salty. If you stayed in the ocean constantly, you would get a little salty, you would get a little dehydrated, so they have to deal with that as well. Buoyancy, so if anyone has seen Captain before, she has that buoyancy issue where she floats at the surface of the water. That is very difficult for her. Salt water is super buoyant. It makes it so you float more easily. So they have to sort of adjust themselves, just how they work and how they live to deal with that buoyancy. Pressure is also a huge one. So if anyone dives, if anyone goes to the bottom of their pool and they feel that pressure in their ears that you have to sort of equalize, that is you going deeper into the water puts more pressure on your body. It puts more pressure in those air spaces. And it can hurt you if you go too deep, too quick. So they dive all the time. A lot of marine mammals dive really ridiculously deep, and they have to deal with that pressure on a regular basis. Finally is heat loss. So if any of you guys have been in the water for a long period of time and you realize that you're starting to get cold, even though it's a beautiful sunny day out, that's because heat is conducted much faster in water. You're gonna lose a lot more heat in water than you are in air. I'm gonna double check. Ooh. Oh wait, Alt H, there we go. I can see the group chat. I don't know why that keeps dropping down, but I'll just keep checking the group chat. If I don't answer you, try waving or something, and I'll go check the group chat again. So how long can you hold your breath? The average for people, I think the biggest for Navy SEALs is like 4 to 5 minutes, and that's what they train to do. I can only hold my breath for maybe 30 seconds, really short amount of time, but sea otters can hold their breath for 8 minutes. Sea otters aren't that big. They can hold their breath for 8 minutes underwater. They're adjusted to be able to do that. Dolphins can hold their breath for 8 to 15 minutes. Manatees for 20 minutes. Seals for 30. And whales for 20 to 90 minutes. That's huge. None of us could hold our breath for that long. It definitely has to do with a couple different factors. So there are different oxygen strategies, different ways that they make it easier for them to hold their breath for that long, make it easier for them to use less oxygen. The first thing is, where are their nostrils? So on humans, my nostrils are right here on my nose. They are pointed downwards. So when I'm breathing, it doesn't really matter, but if I was submerged in water, my mouth and my nose couldn't get above that water easily. I'd have to put more energy into making sure that I could get my mouth and nose above the water and take a nice deep breath. So whales have their nostrils on the back of their head. Actually at the point that when they are diving, anyone ever seen a whale in real life where they come up to the surface and they blow their air out and you can see that beautiful spray? So they have their nostrils on their back, which makes it so they only have to stick a tiny, tiny bit of themselves out of the water to get that air. That conserves a lot of energy for them. It makes it much easier for them to use less energy and less air. Manatees do the same thing where they have the nostrils right on the top of their face. It makes it so all they have to do is stick their nose out a tiny, tiny bit and they could get access to that air. Both species have similar ways they go about this, and they both have muscles that tightly close those airways. So I can't really pinch my nose unless I use my hands to pinch my nose. They have muscles around their nostrils that they could squeeze them shut just by flexing. I can't do that. I could barely flare my nostrils. It's not cute, but they could do that very easily. Seals are special. They actually don't have those muscles in their nose. They have those muscles in their throat. So they'll actually squeeze their muscles closed in their throat so they can hold their breath that way. Wait, Alt H. Nope, that's not gonna work. So sometimes size matters. The bigger you are, the bigger your lungs are. So if you guys remember what I just showed you, the otters start off at 8 minutes and then the whales go all the way down to 120 minutes sometimes. The bigger you are, the bigger your lungs are, and the more you can actually hold your breath because you can get more oxygen on one breath hold. You also have more blood in your system. So oxygen goes into your lungs with all that air. It gets spread throughout your body by your blood, by that hemoglobin in your blood. That's the little carrier that the oxygen pops right on and then gets spread throughout your system on. So the more blood you have, the more hemoglobin you have, and the more oxygen you could carry at once. You could store a bunch of oxygen in your blood system by taking a deep, deep breath. And if you have more blood, you're gonna get more oxygen at once. Otherwise, you could slow the use of your oxygen. So there are two ways you could do that. You could either do what some whales do what some marine mammals do, and you see how, I don't know if you could see my little pointer here, but you see how tiny his little front fin is? See how tiny his little back fin is? So they can actually cut off blood flow to those fins, to those small bits of their body that don't need blood flow all the time, and it helps conserve the oxygen. It uses less oxygen because they're not sending oxygen to all their body all the time. The other way is they could actually just slow down their heartbeat. So that is one way that humans actually learn how to breath hold. If anyone here free dives, they teach you breathing techniques and ways to slow down your heartbeat so your heart isn't beating as fast and you're not using as much oxygen at a time. Next, we're going to talk about the movement in water. I'm also going to check the chat because I don't know why it's not just popping up for me, but that's fine. If anyone has anything super important. Oh no. Let's try this one more time. Okay, if anyone has any super important questions, I'm sure that someone will get me. Yeah, the giant otter can get really, really big, 3.7 feet long. Very cool. I actually am studying otters, They're my favorite. Don't tell the other marine mammals. Don't tell Captain. But they're really, really cool, and they can get really big. Those little river otters that you see at most aquariums, that is not a sea otter, that is a river otter. They live in freshwater and they're smaller, but the oceanic ones, the ones that live out in the ocean, are huge. Next, we're going to talk about body shapes. So one way that you can move more easily in water is you get big. You want to increase your surface area to volume, decrease your surface area to volume ratio. So that basically means that a whale is going to move more efficiently in the water than an otter will, because it's so big and there's so little surface area. Like I said, that water does a lot of friction. So in the air, you don't have that much friction. I'm moving my hands around, super easy, but in water, you feel that pull. It's harder for you to move as quickly. That's the friction of the water. So if you have a less volume in your surface area to volume ratio, it is actually easier for you to move through water. Next is fusiform shape. So if you look over here at this cool dolphin right here, that is actually the quintessential fusiform shape. So lots of fish, lots of different things that live in the ocean, that live in water, get this shape. It's just like an upside down teardrop. It's called fusiform, where you have, I don't know if you can see my pointer, this big bulbous rounded head, and then it tapers off back into a tight little point. That makes it so the water can move really easily over you as you're plowing through the water, just like a bullet. So a lot of different marine creatures are shaped like this, especially marine mammals, just because it saves energy and it makes it easier for you to move in the water. Next are limbs. So you see, we talked about before how tiny his little front arms are, how tiny that little back dorsal fin is. Compared to my body, my arms are pretty big. Like this is, I think it's if you put your arms out to your sides, those are the same length as your height. So they're pretty big compared to the rest of my body. This tiny little fin on the dolphin isn't that big compared to the rest of his body. Cutting back on those limbs, making them even smaller and tighter to his body, means that he could push through the water much more easily without more drag. They only keep their propulsion appendage large. That usually is going to be that tail, that caudal fin on dolphins, even on seals and things like that. They use big fins in the back to sort of push them through the water. That makes sense? Next, swimming is a drag. So I'm gonna move you guys over here. So how do they swim? That also affects how easily it is for them to move through the water. So most use pectoral movements. That means that they do that quintessential dolphin and whale movement where they flex what's basically their abs to move their caudal fin, and that's what's pushing them through the water. Some of them use their front fin. So mostly that's gonna be types of seals. There are two main types of seals, the true seals and the fur seals, and they have slightly different ways that they deal with things. But one of them has really big front fins and really small back fins, and they use those front fins to pull themselves through the water, just like Captain does, just like sea turtles do, and they use those back fins for maneuvering, for making turns and stops. That's a little weird for a marine mammal. Almost all the other marine mammals use that back fin to propel them through the water, and those front fins to make turns and stops. Next is breaching. So has anyone seen, like our little friend over here on the left, that really cool jump that a lot of different whales and dolphins do? That's called breaching, and it actually is something that helps them with their movement. So like I said, there's a lot of drag and friction of that water. It's more so at the surface. So the closer you get to the surface, there's water tension. Maybe the wind's blowing that way, pushing all the water that way, but you're trying to swim that way. So at the surface, it's harder for you to swim. It takes a lot more energy. So what a lot of different dolphins and whales do is they breach, where they are swimming at a depth, just hanging out, going fast, and they say, oh my gosh, I need a breath of air. So they shoot up to the surface. They try to spend as little time at the surface as possible. So they jump out, take a deep breath while they're midair, and then land back in that water. Sometimes it's more efficient to jump than to hang out at the surface for a while, because it uses less energy, it uses less oxygen, and it's an easier way for them to move. There we go. So sound and echolocation. I'm sure that a lot of you have heard about echolocation before, right? It is my favorite thing that marine mammals do. I think it's super cool. It's also something that bats do. So sound travels 4 times faster in water than in air. The ocean's huge, and it's really easy for those marine mammals to get lost. When you go out on your street, there are streets, there are trees, there are houses, you know exactly where you are. because of all the things around you that indicate to you that you remember and say, oh, I know, I make a left at the yellow house and that's how I get home. The ocean's huge, and a lot of time they're just hanging out in the middle of the water column where they can't see the floor and they can't see the surface, so there's not a lot for them to be able to figure out where they are. So one way that they do that is echolocation. Yes, dolphins use it, whales use it. It's huge, huge, huge for them. Marine mammals must modify how they use that sound to help them find their prey and talk to their families. So, time to talk. All marine mammals use vocal and non-vocal sounds to communicate. So they use echolocation that helps them find their prey and find out where they are, but it also helps them talk to each other. The sounds that they make, they're really, really intuitive. They have a huge language, and every sound means something different. So they could talk to their friends and family just like we do. They all have specific languages. Some of them use non-vocal sounds. So at the surface, you could see a seal or a whale slapping the surface of the water with a fin, or sometimes they'll grind up against rocks or sponges and things like that. And those sounds also mean something in their language. The one we're most familiar with is echolocation, but each sound means something specific, and walruses have the most complex vocabulary, which is a fun fact I just learned. I thought that was really weird. I would think that'd be whales or dolphins because we're so familiar with them, but walruses actually have a word for absolutely everything. I added some noises, some of their special marine mammal noises to this slide. I'm not 100% sure you're gonna be able to hear it, so let's find out. Can you guys hear that? Yeah, maybe, no? There we go, thank you. So, best guess, what do we think that is? Any guesses? I'll try and play that one more time. Any guesses? Do we think it's a dolphin, a seal, a whale? Dolphin, very good guess. Anyone else? I don't think so. I think that this chat is gonna be a little off to the side. I'm sorry about that. So that is actually a type of whale. That is one of those sounds that we're really familiar with from a type of whale, yeah, a baby whale. So if anyone's seen Finding Nemo, Finding Dory, how Dory makes those whale sounds, just like this friend over here. I'm not 100% sure which type of whale. My guess would be right whale or humpback whale, but that is one of those noises that they make for communication, one of those loud noises, kind of like a song. Next, let's see if you guys can guess this. Dolphin, good guess. Dolphin, lots of dolphins. So you guys are familiar with how dolphins make that clicking noise, right? This is actually a type of whale. I think that this is actually a sperm whale. So a lot of those cetaceans, those dolphins and whales, make really similar noises. Dolphins usually make that really high-pitched noise. A lot of time they will communicate above water with that high clicking or squeaking. Usually whales are gonna sit a little bit lower. So that is a very deep baritone voice. The cool thing is that the lower the sound, actually the farther it'll usually travel in the water. So a lot of times whales, especially sperm whales, will use this deep, deep clicking sort of noise to just keep saying that over and over as loud as they can, as long as they can, until they run into a friend. Next, let's see. Any guesses? Baby seal? Yeah, seal, perfect. So that is the quintessential seal barking. A lot of times people say that seals are the dogs of the sea. They do use that barking sound that is good for them to communicate, usually above water, and that is really, ooh, where'd my cursor go? That is one of the more common seal sounds you'll hear. What do we think that guy is? Walrus, good guess, very cool. Walrus, yep. So I'm glad that you guys are sort of figuring out it is a pinniped. So walruses and seals are grouped together called pinnipeds. That is a type of seal. I think that's the elephant seal. They are one of the ones that make that really growly, deep noise. That is usually a sign of aggression. Elephant seals are super aggressive, and they will use that to tell each other to back off. Okay. There we go. So echolocation, my favorite. It's super cool. So that's something that usually only cetaceans like whales and dolphins will do. In this really cool little illustration, you get the basic idea. They make a sound, they shoot it out, they wait, and they listen for the sound coming back, it bounces off whatever is in front of them, and then they're able to figure out what it is. They're able to figure out where it's coming from, what direction it is, and what shape the thing is. So that's really, really specialized for the dolphins and whales mostly, but does anyone remember the thing on land that also uses echolocation? It flies, it's small, sometimes it's a vampire. Bats, very cool. Yeah, so bats use the same thing. Bats have those massive ears. If you've ever seen a bat, they have those big, big ears to catch all that sound coming back through the airwaves. But dolphins and whales don't have that. They don't have external ears like we do. So they actually have to be more specialized to be able to understand and hear that reverberation coming back at them. And this is how they do it. So they make a sound. The water is a certain density, and sometimes it's hard for us to be able to make the proper noises that will move through the water at the right density, at the right speed. So the cool thing that the whales do, if you see that green line coming out of them, they will amplify the noise they make with their melon. Actually, we were gonna look at this later, but I like using him as a prop right now. So this is actually a dolphin skull. He has this big, big skull right here, and this part in the back under the dome is actually called their melon. So in there is a huge fatty deposit. It's basically just whipped fat. And it kind of looks like whipped up Jello, squished up Jello, but it's basically a fat that is the same or similar density as salt water. So when they make their noise, it goes through that melon makes it so it's louder, makes it so it has a proper direction, and it shoots it out through the water, and it moves more easily through the water, makes it so that noise is gonna go farther and be louder. Is it true that dolphins evolved from a type of ancestor who gradually crawled further and further into the ocean? Very cool. So Elizabeth, very good background. So dolphins and whales actually did evolve from something that once was on land. So when they look at the full skeleton of a dolphin, of a whale, they'll see in those front little fins that we were pointing out earlier, they actually have finger bones just like we do. In their back fins, they actually have toe bones just like we do. So they evolved from something that was once on land, had arms, had legs, had fingers and toes, and then they went back into the ocean and those re-evolved to being fins, but they never lost those fingers. They never lost those finger bones. Most fish don't have that sort of thing. They've always been fins, and they'll have very different bones than us, but the whales and dolphins and other marine mammals do have all those same bones. That's how we know. This skull came from my boss. We ordered a bunch of skulls for us to use for this really, really cool project, so we could sort of show you what things look like. So that is where this skull came from. Good question. So we talked about how the sound goes out. That green, let me see if I can bring it back. There we go. That green bar goes out, and that's how they make the sound go out. Now that red bar coming back at them actually goes up their jaw and into their ear bones. So that jaw is, again, filled with lipid. It's filled with a fat that's a similar density as salt water. So when it comes back, it hits that jawbone. That jawbone makes it more comfortable for them to understand it. It goes up through there and straight into where their ear canals are. And that is how they easily see what's around them. They make a really, really loud sound out. And then instead of having those big old ears like bats do, they have a fat-filled jaw that sort of targets it perfectly back into where their ear bones are. Does that make sense? Possibly, maybe? Beautiful. If you have questions, feel free to keep messaging me. So what about the heat? The biggest issue that a lot of different marine mammals face is heat conduction. So water conducts heat 24 times faster than air. You can get a lot colder in water, and they spend their entire life in water. We talked about how they're warm-blooded, just like all marine mammals. They're endotherms like us. Captain is an ectotherm. Reptiles are ectotherms. They need to live in a certain temperature water. But ectotherms, I'm sorry. Endotherms need to be able to regulate their own body temperature, and it takes a lot of energy to stay warm all the time. So marine mammals have different strategies for staying warm. I see someone, Alex, very good, has a couple ideas. First one we will talk about is going to be that fur. So otters are one of the ones that use fur. A lot of them, you think of a whale, you think of a dolphin, they're smooth, they're rubbery. They don't really have that thick fur, but otters are the one that really use that approach. They have the densest fur of any mammal. They spend most of their time grooming to keep it fluffy and dry. So if you see an otter, they're always going around, they're always pulling at their fur. They actually have an elongated spine and are super flexible because they need to be able to reach every part of their body to be able to be constantly grooming their entire fur. It has oils in it to repel the water, so that sort of creates a barrier, make sure that their skin doesn't get wet, make sure that they don't lose that extra layer of warmth. And it's not actually the fur that keeps them warm, it's the air pockets that are made by the fur that keep them warm. So sometimes when you go out and it's cold, I'm not sure how many of you from Florida have experienced this, but I'm from up north, and it is definitely something that we experience when it's really cold and really windy. You could either throw on a really thick jacket, or you could throw on a windbreaker. The important thing is that those two things will probably both keep you very warm. You just want to break it so there's a pocket of air between you and the outside world. That pocket of air will get warm by your skin, and that's what's going to keep you warm. Weren't they almost hunted to extinction for their fur? Very good. So back in the day, it was super, super common. People were trying to go to really, really cold places, and we don't have fur all over our bodies. This is all the fur I got. It wouldn't keep me very warm up in Alaska. So what they did is they hunted things like sea otters, like fur seals, things that had fur that they could use to make clothing, make jackets. In 1911, they actually passed a ban because sea otters were almost completely and utterly extinct. They passed a treaty saying no more hunting sea otters, you can't do it anymore, they're extinct, we have to protect them. And now they're actually doing pretty well. The sea otters are doing very well right now. Don't some sea lions also have fur? Yes, so they do have a light coating of fur. Most seals and sea lions and things like that do have a light coating of fur. They shed it. It's not their main source of heat protection, but it is really good, especially because they pull themselves out onto the ice, out onto the land sometimes. So that is one reason they have fur, and things like whales and dolphins that are always in the water don't. So approach 2, their blood. This one's really cool that a lot of people don't generally think about. So marine mammals have adapted to utilize their blood to conserve heat. There are 2 ways to do that. So we talked about before how to preserve oxygen, they could actually stop blood flow to certain parts of the body. They could stop blood flow to those tiny little fins up front, that dorsal fin, things that don't need blood flow all the time. That's also something that they do. It's called vasoconstriction. That makes it so the blood won't go to those parts and they won't they won't lose as much heat. The second thing that almost all marine mammals do, some sea turtles do it, the leatherback sea turtle does it. If any of you guys like leatherbacks, I think they're really cool. They're humongous sea turtles. We're a very sea turtle focused place. They use countercurrent heat exchange. So what that is, if you look over at this right here, I don't know if you can see my pointer. It's basically 2 big pumps. They're big, big artery that's shooting warm blood from the heart, from the core of their body out to all the other parts of their body. And then all of the veins that are bringing cold blood that have been out by the surface. My blood that's at the surface of my skin is definitely colder than the blood that's at the core of my body. So when it's cold and it's going back to the core, instead of just immediately shocking me with all that cold blood at my heart, it rubs up against those arteries with hot blood going out, and it steals some of that heat. So the blood that's coming back to your heart is not as cold as it was. It conserves some of that heat, so you aren't getting as cold. Does that make sense? It's basically 2 pipelines, one with cold water, one with hot water, pressed up against each other, and the cold water pipe is stealing some of that heat from the hot water pipe, and that is how they conserve that heat. I think that's one of the more confusing things about marine mammals, so feel free to interrupt me in the chat if that doesn't make sense. And then finally, what our friend said before, approach 3 is fat and blubber. So many mammals utilize blubber to stay warm. You'll see whales, like our friend over here, very, very chubby, gets that really thick fat layer. They use it as insulation instead of fur. So the point of fur and fat is to just create a barrier between their muscle and their blood and all the things they want to keep warm and that cold water. So it uses the same sort of idea, just a different approach. Blubber is also constricted. It's constricted the blood vessels at the surface, so there's less heat loss, which, there we go, I thought I had this one. So since there's so much fat at the surface, since there's so much blubber at the surface, it actually constricts those blood vessels. It tightens them up, doesn't let as much blood flow to the surface of the body. And that's another way that it helps conserve that heat. So there's so many different approaches to the same problem. We have our seals, we have our whales, our manatees and dugongs, and our sea otters. So we mentioned a bunch of different problems at the beginning, but I just wanted to cover my personal favorites, the ones that they all do different really cool things. And today we're going to look at some of the different approaches. So first we will start off over here with our manatee and our dugong. So I pulled out the skull a little early. It was supposed to be a surprise, but I really like them. I think they're cool. So we're going to start off, we'll start off with the dugong. So has anyone seen a dugong before in real life? Yes, no, maybe so? No? Okay. Has anyone seen a manatee in real life? Yeah, we have Florida manatees here. Actually, let's start with the manatee, just because we're familiar with the manatee. So, looks like this, our happy friend over here, a nice gray sea potato. Lots of times, like the mermaids of the sea, we love them. Does anyone know what their closest living land relative is? Elephants, very good, Carly. So the dugongs and manatees, their closest living relative on land are going to be those elephants. They are called the sea cows just because they graze on grass. They are sort of a similar big old shape as a cow. So they do sort of the same idea, but they are really closely related to those elephants. So this is our manatee skull. Oh no, actually I'm going to move you guys a little bit farther away so you get a better look. Can I stop sharing? There we go. So this right here is going to be our manatee skull. So the manatee is common to Florida. That's why I bet a lot of you have seen it, but it's all over the world. It is living in fresh water, it's living in salt water, and it's living in brackish water. So it could live in basically any of those different variations. Some of them are in Florida, some of them are in the Indo-Pacific, some of them are all the way over in Australia, but they're all really similar morphologically. They're all very similar structurally. So first thing you'll notice of this big old skull, there we go, are these big old eye holes right here. So you see these and you're like, huh, the manatee must have a really good sight, right? And must use those eyes. Now, if any of you guys have seen a manatee in real life and you see them run into things and you see them not looking around, not doing so great, you'll be like, I guess that they don't pay attention. But really, those eyes, even though they're pretty big, they don't function really well. They don't have great eyesight. So they rely mostly on touch and on hearing. So the big pockets back here, I don't know if you can see very well. The big pockets back here are actually air pockets by the ear bones. And having big ear pockets right next to that ear bone lets the sound reverberate and makes it easier for you to hear what's coming at you. So they really rely on that sound. And manatees actually are one of the few that still have quite a bit of hair. So we talked about how marine mammals have hair. Usually whales and dolphins are born with just like a little bit of whiskers, maybe a tiny baby mustache when they're first born. It's really cute, but eventually that will fall off. Manatees are covered in what we call vibrissae, which are just tiny whiskers that they are covered with all over their body, and they use that to sort of sense what's around them. If any of you guys have a cat, maybe, yes, not so much. Well, cats use their whiskers for the same thing, where they don't have to be touching something, but when they're near it, they use those whiskers to sense what's around them. So manatees are covered in those little whiskers, and it helps them sense what's around them. Finally, I'm just going to pull his skull apart, really cool and creepy. You can see his teeth. I'm going to pull that right up to the screen. So you see all these cool molars right here. Manatees are specialized with what we call marching molars. So does anyone know what manatees eat? Yes, no, I think that was to the cat question. Plants, seagrass, beautiful. So manatees eat mostly seagrass. They can eat throughout the water column, which means that they are sometimes swimming in the middle of the water column. They might accidentally eat a fish. They might accidentally eat a jellyfish. They might eat a bivalve just for fun. But they are mostly going to be eating that seagrass, and they have these flat molar-like teeth to grind up all that fibrous material, to bite through all that seagrass, bite through all that vegetation. They have what we call marching molars. So if you look back, I can't actually see. If you look back here where this one's just growing in, they actually are constantly growing teeth. So we as people, we start off with baby teeth, they all fall out, and then we get our adult set of teeth. Manatees actually have what's called marching molars. They are constantly growing new teeth. Elephants do the same thing, where they constantly have like a little conveyor belt going of a new molar popping up in the back, and then pushing the old ones forward, and that front one, which has been worn down from chewing on a bunch of stuff, will just pop right out and fly away. Well, float away. They're in water. So manatees have those flat molar-like teeth and those marching molars, which are constantly pushing those teeth forward. Now, the dugong is really different, even though they're very similar, even though they're the same order. And when we think of dugongs, when we think of manatees, we think, oh, they're the same. Does this guy look the same to you? Nah, right? He's really funny looking. He looks very, very different. It doesn't really look like a cow, but since they do eat grass, since they eat seagrass and cows eat grass, people oftentimes compare them. But this guy is really special. My dugong friend is really cool. Even though he and the manatee are closely related, there's a bunch of really important differences. So I'm just gonna take the tops of their skulls. We're gonna be a little macabre here. The manatee skull is usually a little bit smaller, if you can see here, but the manatee itself is usually a little bit bigger. So manatees are gonna be a little bit bigger than dugongs. They're gonna have a paddle-like tail. So if you see a dugong in real life, they have a fluke, which is the same thing as dolphins and whales have, that special tail that sort of branches off into 2 points on the end, whereas the manatee has just that one big paddle. Manatees can live in fresh and brackish water, whereas dugongs can only live in salt water. They're usually in the Indo-Pacific Oceans. But they also eat a diet of grass, a diet of, ooh, did I mismatch the skulls? No. Oh, well, the bottom parts are mismatched. It's fine. These are the two ones. This guy's the manatee, and this guy's the dugong. They also eat a diet of seagrass, but the cool thing that they have are these tusks. What did we say that their land animal ancestor is? Anyone possibly remember? Not hippos, but actually the elephant. They have these tusks just like elephants do. The males will usually have bigger tusks than the females, but they both have them. And they use that to rip up the seagrass from the ground up and eat it whole. So they actually eat the roots, whereas manatees are more like grazers. They're gonna try and just cut down that seagrass, kind of like Captain does, but they have their tusks that rip that up from the bottom, and they both have these really cool muscular lips that sort of suck it up. So dugongs eat off the bottom. They're what we call benthic feeders. So they only can eat things that are right below them. That's why his face is tilted. You see how strongly his face is tilted downward, especially as compared to the manatee, who has a pretty normal face. Dugongs can only eat things off the bottom. They're benthic feeders. So they're constantly pointing downward, ripping up seagrass, eating it up. Sometimes they'll accidentally eat something with the shell. Sometimes they'll accidentally eat something that's under them. But they really are just herbivorous. They're only going to be eating that seagrass. Ooh, I'm going to put that down. Okay, I think we only have a few minutes left. So if we cut out, I'm so sorry, but I'm going to move on to my favorite part of the day, which are the dolphin. Someone before said that they saw the river dolphin. Has anyone seen one of those before? Yeah, very cool, Alex. Yeah, river dolphins are weird. River dolphins are my favorite. So, hi guys, sorry that we got cut off there. We talked a little bit about the dugongs and manatees, but we wanted to talk a bit about our cetaceans, our dolphins over here. So, bringing our skulls over. Oops. This is our bottlenose dolphin skull. It's the one that everyone's super familiar with from aquarium, SeaWorld. It is the quintessential dolphin. It does have really good eyesight. It can actually see above and below water, just because it does spend a lot of its time at the surface, jumping out of the water, checking out what's around it. So it does have really, really good eyesight for both above and below, which is very weird for a marine animal. Most are usually really good in the water, but not so good above water, just like Caption, our sea turtle. She has pretty good eyesight while she's in the water, but when she pops up and looks through the air, her lenses aren't adjusted for that. It's a little funky for her. Also, you can see a huge size difference, so they actually have pretty big skulls. That is for their melon. We talked about echolocation earlier, and how they use that melon to sort of funnel the sound out, make sure that it is going the correct direction, right amplitude, make it very easy for them to hear what's going on and hear what's coming back at them. So they do have a big melon for that, as well as a really thick rostrum. This nose part is called the rostrum. It's pretty thick. You can see its teeth right here. It eats throughout the water column. Lots of fish predominantly, sometimes things a little bit bigger. Sometimes it'll go after things along the bottom, benthic organisms. But its teeth are pretty big, but they aren't as thin and interlocking as this guy here. It has a lot of muscle in this rostrum to get through all of its food supply, but it doesn't need the same type of modifications this river dolphin does. So that is our regular old dolphin, our bottlenose dolphin. I'm gonna place him over here. And we're gonna talk about my favorite. So this is the Indus River dolphin. So there are a couple different river dolphins. Back when there was access to the ocean in those same rivers, dolphins would come in and out, and then something happened that sort of cut off the access, and the dolphins that were trapped in there evolved to be adjusted for that environment. So these are freshwater dolphins in the Indus River, a couple different rivers, I think Ganges River in Asia, and then there's also the Amazon River dolphin, that really, really famous pink one, down the Amazon River. But this guy's an Indus River dolphin. They usually have very similar morphology, even though they evolved separately. So they got cut off separately, some of them at different times, but they have really, really similar adaptations for their special environment. So the Indus River is really mucky, really muddy, and kind of polluted, so it's not very easy to see through that water. So the Indus River dolphin actually is functionally blind. Their lenses are actually flat, so they can only kind of see light differentiation, not really well. Sometimes it helps them to be able to tell which way is the surface, which way is down, but really they rely heavily on that echolocation. That's why they have that specialized melon right here. It also gives them a little bit more of an air pocket around those ear bones, because like we said, when they make a noise and it goes outwards, they use the melon, but when it comes back in, they use that jawbone, bring it back up to where the air pockets are at those ear bones, and that's how they hear. So they bring that noise back up here, and a little bit more air around that eardrum, around those ear bones, make it easier for them to utilize sound as their main sense. We also talked about the bottlenose dolphin's rostrum. So this guy has a very thin rostrum, very pointed. That's because they actually use it to dig through the muck at the bottom of those rivers to help them find prey. It's very, very difficult for them to find prey in those confined spaces with that really murky water, so they have to be utilizing every opportunity they can to get a meal. They also have interlocking teeth, which our friend over here doesn't. He does have really big teeth, but they just sort of close right on top of each other. This guy actually, those really thin teeth interlock because when they bite onto a piece of prey, they want to make sure they can hold onto it and swallow it whole. They're not going to be chewing it, they're not going to be ripping it up, because they need to make sure that as soon as they get it, they are keeping that meal. If they lose it, it's really, really bad for them. It's really hard for them to find food one right after the other in there. A really cool thing about the river dolphins is that they also can swim on their sides. So that's not really common for ocean dolphins, for bottlenose dolphins. You see them doing that up and down fluke motion, diving up and down just like you would at an aquarium. These guys actually turn on their side. They still use that up and down motion, but swiggle side to side to get up into really shallow water, so they have more access to different food options. So they really are specialized to work with the environment that they're in. It is a very harsh, very difficult environment. They are a little bit smaller to fit in those areas, and they also don't live in a pod. So very common for us to talk about dolphins and whales and things like that, living in a pod, having a very strong community culture, having a very strong familial bond. But these guys, since there is such limited resources, they are going to be living just by themselves, trying to fend for themselves, and doing the best they can. They are threatened. So a lot of different marine mammal species are threatened. They have been hunted for blubber, for fur, for things like that. But the Indus River dolphins, they are a very small population to start out with, and they were also hunted until they were not doing so well. The pollution in the rivers are also not helping them any. So it's really important to know as much as we can about all these different awesome marine species to know how we can help protect them. So thank you very much for joining us. I'm sorry that we were cut off earlier, but we will be doing another class next Thursday. So we are doing a freshwater class Thursday at 1 p.m. So if you want to come back, learn all about that. Otherwise, we will be recording it and posting it right here. Feel free to email us at meek@nova.edu with any questions, and hopefully we'll see you soon.